Good afternoon, everyone. I hope you can hear me loud and clear. How are you guys today? You, you guys are okay, everyone?
Yes, we're okay.
Great, thank you, Aizat. All right. Um, so today we are going to finish up chapter 5, which is we are going to look at our final topic, which is the energy dissipator structure. It's actually is the struktur pelesapan tenaga lah. That means a structure which dissipate, which helps to dissipate energy. This structure is commonly built at the bottom of a spillway. That means at the toe of the spillway to reduce kinetic energy of flow. Now, these structures are built to reduce damage. Now, since it's reduced the kinetic energy, of course, it's going to reduce the damages lah caused by this the existing kinetic energy of flows. Um, what else? Okay. In our syllabus, we are going to look at just one type of energy dissipator, which is a USBR Stirling basin type 3. It is a very stable with a steep jump front and less wave action lah downstream because it has actually three structure, right? Um, one after another. Okay. Um, it is recommended for discharges up to 18.58 meters squared over second per basin width. If you look at it, the discharges is actually in the unit of meter squared over second because it's actually over meter width of the basin. Fruit number between 4.5 to 17. Now, this fruit number is the upstream flow that coming from the spillway one, which is the Y1. So, it's very high energy flow. Therefore, the fruit number is much more than one lah, basically. All right. Normally, I didn't go through, all the text lah. You can read it by your own. Now, USBR, okay, 1984. In its manual, right, it has 10 types of Stirling basin. Now, apart from USBR, which is the United States Bureau of Reclamation, you also have other, Stirling basin designed by individual or an agency. There are so many types of Stirling basin, and each type of Stirling basin has its own, um, you know, um, cater for specific discharges, specific type of dam, and then it's actually various lah, right, kind of type which suit the needs of or the requirement of a certain dam or spillway. All right. If you look at this Stirling basin type 1, okay, it's just a flat one. Now it this Stirling basin type 1, right, is actually is susceptible to damages lah because it's flat, right? It doesn't have structures which can try to reduce it. It does because you put concrete floor. If it's earth, it's going to scour the earth away, all right, the soil, everything. However, you put a concrete, but still it can cause damage. The high kinetic energy of flow can cause damages lah. Okay, you also have type 2. Type 2, you have like tube blocks and also the end seal, all right? You have type 3. So this type 3 is what we are going to learn or what we are going to design in today's lesson. So you have tube blocks, buffle piers, and then end seal. So you have three types of structures there, all right, for Stirling basin type 3. And then you have type 4. If you look at type 4, right, you can see that, the flow is slightly lower, lower velocity of flow. All right, so each type of sealing basin cater for the needs lah. All right. So the first one might cater for lower flow, as not to cause damages to its, the floor. Type 5, all right, you just have one end seal right at the end of the platform there. You have type 6, all right. Type 6 is such, okay. You have flow. Sometimes the spillway is not, you it's not just, there are certain type of spillway, for example, like morning glory. That means water will go down in a, sort of like, morning glory flower, right? So it has like tube, cylinder that goes down, so it can go out from here. All right. So with ceiling basin type 6, all right. And then you have ceiling basin type 7, 8. Okay, if you look at it, it's various type, to cater for various design of ceiling basin, and then various design of spillway, and then you have type 9, 10. Okay, and then all those lah. All right, so various type of ceiling basin. Now, if you look at this, right, um, I'm just showing these images because I want to show you, for example, this floor is being damaged due to high action of flow. These images, okay, if you look at this has like some sort of, chip blocks. Look at this size. It's humongous. It's so huge, right? Compared to the person who is standing next to it. You can look at people, right? Okay, so this is like so huge. Of course, it depends on the size of, you know, um, the size or the volume of water that is coming out, the size of your dam, all right, the height of dam and all right. And then you also have, a moderate size. This is, almost like 3 meter high, you know or more. Okay. And normally a person is like 1.6 meter, right? It's about 1.6 meter, so this is like more than double of height. So you can see the structure is so huge. All right. This is example. You see water coming down. All right. It actually, if you put blocks, right, it blocks, it actually blocks the flow of the water, and then it can reduce the velocity. If you look at this, look at this is type 9. If you still remember, right, there are so many types, right? You can see this is type 9, right? This is type 9. If you have, just now I've explained it, right? Similar to type 9 lah. All right. Um, when you are working on your master's or PhD, you probably will be using, this is, I think, this is commercial flow 3D, commercial numerical modeling or software. You'll be using it, and you can simulate such a, um, flow. This is flow when you release flow. Okay, this is initial condition, release flow. This is what you get lah. Okay, you can see, it actually helped to reduce. This is, this has less velocity compared to, the flow coming down. And then you have the scale. Okay, the one, all these are the velocity which has high velocity, and it actually reduces the velocity here and further up to zero lah at the end if you look at it. All right. This is with time, simulation with time. And then there's another simulation I want to show you. This is the tube blocks, baffle, pierce, and end seal, right? This is type 3, sealing basin type 3. You see how water rush down? Water rush down, and then it's being, the velocity is being reduced by all these blocks, right? Set of blocks. Okay. This is water coming down. Okay. This is what actually you can do this using your whatever commercial software available lah. All right. You got to, even I think even when you are studying your you got you actually have the chance to use hack Rust. either HackROS or HackHMS, one of the commercial software which is available in public domain, which is free lah. Basically, you can do some simulation as well. Of course, if you want to do all these 3D images, right? Normally you need another module lah to help you to plot all this, right, with time. Okay, this is what we are going to learn in our class today. So this is the right direction of flow. We have, a set of chute blocks. If I look at these images, right, only these images, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 tube blocks. And then 14 buffer pairs. And here's the thing. The number of chute blocks, all right, and buffer pairs, not necessary, it has the same number. It has actually there is a formula to determine how many numbers. Basically, once you have determined the width, all right, the width of the blocks and the space, okay, let's call it, you know, W plus S would actually give you one set of tube blocks. That means one tube blocks, right? So the width of your spillway, when you divide by this S plus W, you can get the number of tube blocks that you are going to place. So actually S and W is what we are going to design. We have S1, W1, and now of course we also have H1 lah. All right. And also this has the same, connotation as well. You have W3. This one you have thickness lah. And then you have height H3. And then you have space S, space 3. Now, why there's no 2? 2 is in fact, all right, is the distance between tube blocks and buffer pairs. You have L2. Then this distance, right, of your steaming basin is L, all right, the length. And then you also have end sail. End sail, you also need to know the height. Of course, you also have, the slope here. Now, this slope here, all right, it's actually placed on, depends on the slope of your spillway. It is actually, this tube blocks is placed on the spillway itself, on the sloping floor of the spillway. And then you need to provide the, the Z, the slope here, of course, is a constant, as well as your end sail. Okay, these are what you are going to design lah. All right, you are going to determine S1, W1, L2, L, S3, W3, T3, and then what else? Z, Z3, and then Z. You have 4, right? Z4, H4, all this. Okay. So this is a smaller one lah, I believe so. Okay. All right. So we have 3 sets of blocks, the tube blocks. You can call it block A2, all right, to represent tube blocks. Block B for buffer pairs and block C for end sail. So this is what you are going to determine, all right, all this. S means spacing, all right, the spacing between the tube blocks. W means the width of the block. H is the height. I don't have the slope here because it depends on the slope of your spillway. And then the height, okay, of the buffer pier. And then the slope, okay. You see water coming down, all right? It will be blocked, okay. That's why you have, vertical face here. It will try to, reduce the velocity of your flow further, okay. And then it will try to slow your flow down, okay, with this face, all right, with a sloping face, which has a slope of 1 to Z4, okay, and height. Similarly, you have S4, the spacing, and then you have the width, okay, of the buffer pairs, all right, W3. And then you have thickness, which is T3. Sometimes, I'm not. Sometimes the formula give you the thickness for T4 also, so you have to find it out. Now, when if there's a question that asks you to design Stirling Basin Type 3, you need to give all this dimension. Because here's the thing. When we are the engineer who design all this, right? Of course, you also have contractor who want to build this. Of course, they need to know all the dimension. If you are missing one, that means the construction cannot be continued then, because contractor don't know how to, what is the size and things like that. Once this is known, then contractor can proceed. Of course, you also have to estimate how many number of chip blocks and how many number of buffer blocks. Okay, I'll give you the formula later, okay, which is B divided by S plus W. Similarly, for buffer pills as well. All right. Now, of course, you don't need to determine the number of end cell because there's only one, right? Okay, it's continuous. It's just one cell, right? Okay, then these are the formula. Okay, you see, let's look at the number of blocks first. B, a number of block A. Okay, is B. B is the width, or it could be this width as well. All right. This is your B divided by S plus W. So once you divide it by this, you can get how many set they have. So number of block A. That's why I'm using S1 and W1. For number of block B, okay, is B divided by S3 plus W3. Okay, B divided by S3 plus W3. So you can get the number of blocks as well. Okay, we will give this table to you in your exam. See how it's not, it's basically you need to understand how to use the formula basically. All right, look at this. Once you already get y1, if you get y1 correctly, that means the depth of flow coming down. All right, of course this fruit number is very high lah. All right, it's much greater than 1 lah. Okay, then you can easily determine what is H1, W1, and S1. H1 is equal to Y1, S1 is equal to Y1, W1 is equal to Y1. Basically, H1 is equal to S1 equals to W1 equals to Y1. Settle. Then you have designed your block A. All right. Then, of course, once you have designed your block A, you need to determine how many number. Remember, sometimes we give you this formula, but I'm not. Sometimes this is not available. Sometimes it's given, but I think rationally, I think this is very practical, right? You can actually find the number of blocks. You just have the width divided by the width of one chip block plus the space. Then you can get number of blocks. Okay, then after that, let's go to block B. Block B, you still need Y1. However, if you look at it, the rest, okay, of SW T, T is the thickness, okay, thickness depends on H3. So you need to find H3 first. However, H3 also depends on fruit 1. That means once you have Y1, you need to find fruit 1. Okay, fruit 1 means fruit number based on Y1 lah. That means you have V1 over square root GY1 lah. Alright. Sometimes, right, if Y1 is not given directly or explicitly in the question, you can use this formula to find it. You should know that, this actually Q is equal to A times V. B times Y is your A lah. Basically, we are using rectangular section. All right. rectangular section. You have Q equals to BYV lah, which is AV. Okay, you'll get back right this formula. Now, once you have H3, okay, you can find for S3. Basically, S3 is equal to W3 also lah, which is 0.75 H3. Then T3, the thickness is, of course, it must be smaller lah. Therefore, it's 0.2 H3. Now, Z is 1. Z3 is 1. So you should know that this is 45 degree. Okay, since it's 1 to 1. So it should be 45 degree lah. Okay. This is constant. It's always one. The slope is always one. Okay. Now let's look at block C. Block C. Now the Z, which is the slope, is 1 to 2. This is constant as well. It's always 2. Okay. So don't worry. Okay. Basically, some of the answer is provided already. You won't get this wrong. But however, if you want to design it, you need to write this down in your answer, right? You need to write Z3 should be equal to 1, because if you are giving your design report to the contractor, right, or your design to the contractor, of course you still need to provide this. If not, you know, your contractor won't, I don't think so. You want to provide the equation to the contractor and ask them to calculate it yourself, right? Themselves, right? Okay. Now, how are you going to determine the height of end sail? Is fruit divided by 18 plus 1 times y1. This is actually readily available. If you can calculate for H3, that means you can calculate for H4 already. Okay, now, hope everyone is clear so far. If you have questions, please stop me. Now, what is the distance, all right, from your tube blocks? If you look at this, L is the horizontal, horizontal distance. What is the distance between tube blocks to buffle piers? Is L2. Now, what is the formula of L2? L2, here's the thing, depends on Y2. I hope you still remember. You can actually get Y2 because here's the thing. You know that this is supercritical, and you want to create subcritical. You want to create subcritical flow. So therefore, you will expect hydraulic jump to occur lah. So your Y2, you can actually get it from your conjugate depth equation. You can get Y2 divided by Y. I hope you still remember this equation here. I hope this time I get it correct lah. Okay. 1 plus 8 fruit 1 squared. Okay. So you can get your Y2 here using this expression here. Now, okay. Now, how about L? L, you can get it from the chat. Now, sometimes, student ask me, what if the chart is not given? Then don't worry. You just find up to YL2, all right? You don't have to give me L if no chart is given. Now, where is the chart? We will come back to that. Okay. Now, this is the chart where you can find your L. Okay. Now, of course, you need to know your fruit number first, and you have to get it correctly. Okay. Once you have, let's assume your fruit number to be 11. If your fruit number is 11, you draw one vertical line up until it, intersect with this curve here. Then draw a straight line. It will give you L over Y2. So your L is, assuming this is about 2.76 times Y2. All right, that is how you get it lah. Okay. Then let's go back. Now, if you need to find fruit number and then you don't have the velocity, and if these are provided, you can find your velocity using this formula, which is square root of 2g h1 minus H dot divided by 2. All right, just in case, eh? So now you can, this is where your velocity, upstream velocity is, the depth of flow upstream and then downstream. All right. So this is the conjugate depth equation, eh? Okay, these are the steps to help you. All right. First, you need to find V1, Y1, fruit 1. Because once you find V1 and Y1, you can get your fruit number lah. And then you need to determine Y2 to get your, to solve for your N cell as well as your L, L2 and L. Okay, then you can determine the length of basin. If chart is provided, okay, if chart is not provided, you still can determine L2, right? Then after that, you can solve for block A. You can design for block A, find the height, the space, the thickness, the width, all right? And then the number of block. Okay. Okay, quantity of chip blocks, which is the number. Then find where you are going to place your buffer piers. That means at a distance of L2. Then you design your block B. Find the height, the space, the width, the thickness. Then determine how many number of block B are required, okay, for the specific width or specific. Then you determine for the end sale. Now, remember I asked you to give value of Z3 and give value of Z4. This is important. Don't miss this out. You'll lose marks here. Okay. Remember those. I hope you are clear. Let's look at one exercise. Now, this will be the last. I think I only have one exercise for this because it's very straightforward. I have 8-meter wide weir of a dam. So this is your B. Okay, discharging. This is your Q, 80 Qmax of flow with H1 30 meter. So this is 30 meter. 30 meter. You can imagine how high, huh? Okay. And then H naught 5 meter. 5 meter is like 3-4 times of us. Okay. Is high. Okay. So design a USBR and USBR sailing basin type 3 downstream of the spillway. So you have to design this. Okay. So I need to find, V1. Now, since I need to find Y2, I need to find fruit 1. If I want to find fruit 1, I need to find V1 first and Y1. Y1 is it given? Y1 is not given, eh? Okay. But you can determine Y1, okay? You can determine Y1. Once you have V1, you can actually find Y1 using Q, okay? Because you know that Q is equal to A times V. If you are using 1, that means A1, V1. Now, this is, assuming this is rectangular, you have A would be B, B, Y1, V1. Okay. So once you have your V1, you can find Y1. Since this is given, Q and B is given. So you can find your V1 first. Substitute G, H1 is 30, H0 is 5 meter. So you can solve for V1. Once you solve for V1, you can find your Y1, which is Q divided by B, V1. Okay. Once you solve for Y1, okay, you can find fruit number, which is V1 over square root G Y1. Now, once you have solved for fruit number, you can solve for Y2. Then the rest you can solve for, you can design the Stirling Basin type 3 already. Okay. So you solve for V1. Okay. Then you'll get Y1. Now, you have to try this out yourself because you need to know. Sometimes when you key in calculator, right, you might forgot to have, the brackets in your calculator, things like that. You need to try it at least few times, right, to get used to it. And then, for example, you can, then the next step would be to find Y1, and then all this. All right. So I think, of course, you need to, try to solve this using your calculator. I've explained this earlier, the steps, so you can get, finally, Y2 is 6.68. Now, some of the, rationale that you have to know, okay, when you are doing your calculation, whether it's correct or not. Y1 is definitely greater than sorry, Y2 is definitely greater than Y1. Okay, because Y1 is subcritical, all right, state. Y2, sorry, Y1 is supercritical state. Okay, because it has high energy, right? Okay, so this is supercritical. Uh, so that's why it produced, fruit number of 11.3. And then this is wrong jump already, if you still remember. Okay. Now, determine length of basin. You see, uh, from the chart. Okay, let's look at the chart. So we have fruit number of 11.3. 11.3. So I have 11.3 somewhere here lah. Okay, so I get about, about almost the same lah. All right, which is about 2.76 as well. Okay, if you look at here, I put it here 2.75. All right, so I have L equals to 2.75 Y2. All right, times Y2. My Y2 is 6.668. So my L is 18. So now when you want to place your here between these tube blocks and buffer piers, all right, the distance will be 18. Okay, 18.3 lah, meter, 18.34 meter. And then, uh, okay, and then determine H1, S1, W1. Okay, so you can determine quantity for block A. Now, H1 is equal to Y1. Y1 you have already found it, which is 0.4305. Now, I don't mind if you write H1 equals to S. Okay, sorry. Let me. I don't mind if you want to write, H1 equals to S1 equals to W1 equals to 0.4305 meter. I don't mind, but you need to write this out, okay? And then, because you don't have to write it so many times, right? So you just give me like this, okay? Or I think I'm been missing one, which is equal to Y1, okay? Equals to this, okay? And then you have, you need to determine how many blocks, right? You need to tell the contractor how many blocks they need to put, right? So number of blocks is the width of a channel, which is 8 meter, divided by the space plus the width of block A. Okay, so you have that. See, coincidentally, or the formula is given where S is equal to W. Okay, you can also give, 2 times this 0.4305. 4305, it doesn't matter. So you get 9.391. So you can put 9 blocks there lah. Okay. Then after you have designed, oh, sorry, just now is L. This is L. Okay, okay, when I inform you just now, right, that is L2. This is L2. That L is actually this distance, all right? This is your L, okay? All right. Which is 18, All right. Now, then determine L2. L2 should be shorter than your 18 lah. meter, right? Which is, the distance between tube blocks and buffer piers. The formula would given is 0.8 y2. So you have 0.8 times 6.668. So therefore you have 5.334. Okay. So therefore, all right, since you have fruit number y1 available, you just substitute to find the height of your buffer piers or block B, and then you can then once you have H3, right, you can determine for S3. Once you determine S3, S3 is the same, W3 is the same as S3 lah. So you can write out, S3 equals to W3 equals to this 0.75 H3. Then you can solve for it. Then T3 would be 0.2 H3. Okay. And then here, please make sure you write this out. Okay. And then finally, you need to determine the number of block B. The equation is the same lah, except now you are using space for block 3 and then the width for block 3. So, you get a number of 4.9. You can use 5 blocks lah, all right? Finally, okay, you determine for H4, which is the end seal. You just use the formula, which is fruit divided by 18 plus 1 times y1. Okay. You get 0.7, which is the height of your end seal. Then you need to write this out to Z4 is 2. Okay. Now, if you look at this, okay, if you look at this, the height of the block A is about half of us, right? Our height is 1.5, right? So one third lah, about one third of us. Okay, that's huge, all right? The block is huge. And then how about this? Buffer piers is even larger, which is double the tube blocks. If you look at, the height. Oh, the height here is more than double of your tube block just now. So it's as high as some of us. All right. So you have about 1 meter. Now, the next the next slide, right? I'm going to just go through what is the largest dam, tallest dam. That's why initially when I show this photo, right, you can see. Let's go back here. You can see, this is so huge. This is to cater for larger amount of water coming down and higher flow. All right, this is huge too. All right, compared to what we just designed earlier. So let's go and let's check out what is the largest, tallest dam in the world. So the world largest dam by volume is the Syncrude Tailing Dam. Well, this dam is about 100-meter tall. It's more or less 100-meter tall. Right? It's not the tallest, but it has huge volume, the largest volume lah. All right. The volume is 540 million meter cube. Okay, that is the volume, all right, compounded lah by behind the dam, all right, in the reservoir. Now, the world tallest dam, all right, is the Nurek Dam, which is in Tajikistan, all right. This is 300-meter tall, all right. It's very tall, right? Okay, this is the tallest lah. Okay, it says currently because you always have people want to build the tallest building in the world, the tallest this and that, right? The tallest structures, in years, all right, coming years, there will be people building higher buildings and structures. Okay, world largest hydroelectric plants would be this Itaipu Dam. This is the Itaipu Dam. All right. Itaipu Dam, it can actually produce 90 billion kilowatt of electricity. All right. The second one would be the Three Gorges Dam lah. Okay. So this you have it. Right? You can imagine all this, mega structures in the world. You can actually find out about, there are numbers of dams in Malaysia. You can, I think, when you Google them, you can find it. There's a list. They also give you, I think, in Wikipedia, they also give you, the height of the dam, and as well as the width and other characteristics as well, right? Of dams in Malaysia. Okay, you can try this out, activity 5.1. I'm going to share the solution. Please remind me. Okay, sometimes I forgot. Okay, this is in reality lah. Okay, this is what you are going to see lah. Okay, so that will be the end lah of our chapter 5. So you guys, do you have any questions so far? If you don't have question, right, could you please I am I right? You are supposed to submit your assignment for chapter 4 by today. And then you also have, I think, assignment 4 only 2 questions. Also assignment 5, there are not many questions because I between semester I've reduced the number of questions already. So you also have 1 week due to submit your assignment 4. Assignment 5, sorry. 4 you're supposed to submit today, and assignment 5 you're supposed to submit next Wednesday lah. All right. Any question? So next Sunday we'll start chapter 6, huh? So we have 2 weeks to go. All right. I think I can finish it in 1 week, and I can help you out with your project lah if you need any help with your project. Do you have any questions so far?
No, doctor.
Okay, Auni. Auni faham tak semua?
Faham. Sebab straightforward kan.
Ya betul, faham pun. Saya nak tunjuk calculation, takut you all boring juga kan. So you guys can try it out lah yourself, right? Okay. If you don't have any question, then I'll see you on next Sunday then. Alright, thank you guys.
Thank you, doctor.
Thank you.
Doktor, kalau assignment
yes,
4 tu
Abang.
kan, upload lambat sikit boleh tak? Dah terlupa doktor.
Apa dia?
Assignment 4 tak buat lagi.
Tak buat lagi Nak bila tu?
Esok boleh?
Esok Okay, saya bagi hantar assignment for Jumaat lah. Saya
Boleh.
extend sampai Jumaat malam Alright, okay. Okay, I'll see you guys Bye-bye.
Thank you, doctor.
Alright.
Thank you, doctor.
Okay. Thank you.
Thank you, doktor. Bye-bye.
Thank you, doctor.
Alright.
Thank you, doctor.
Doktor,
Yes, Aizat.
Doctor,
Yes, saya.
I have a question for the project.
Okay.
The question 1 cakap kena state. So maknanya
Bagi tahu je, nyatakan
do we need just kena state nama dia or nyatakan saya. So they no need explanation ke apa.
Sebab saya sebenarnya nak cuba mudahkan projek you all. Memang question 1 tu memang minta state je. Saya nak tahu you all aware ke tak ada benda tu yang required by the authority lah untuk design. Yang kedua tu yang you kena buat banyak sikit kan? Okay ya Aizat?
So the total 20 pages is including the cover and
intro
the table of
flash
contents.
Okay, faham.
Aizat, pre-real later Aizat yang nak buat intro semua tu, mungkin you nak buat intro tu dekat soalan 2 kot. Yang nak introduction tentang
Betul.
soalan 2 tu boleh. Maknanya soalan 1 mungkin you ada satu page, soalan 2 tu you start dengan page barulah pun boleh, tak ada masalah. Okay Aizat?
Faham. So format dia bukan macam report apalah, just
mungkin
simple,
formula soalan 2 tu macam ada report sikit kot. Kalau saya nak buat table of content, saya akan cakap mungkin muka surat satu tu, soalan satu, muka surat dua tu, adalah intro untuk soalan dua dan sebagainya. Kan?
Doktor.
Yes, Syafiqah.
Kiranya yang soalan tadi tu, kiranya macam soalan satu just jawab je. And
Ya,
then yang
betul.
soalan dua baru masukkan report lah, start dari intro sampai conclusion.
Pun boleh. Boleh. Tak ada masalah.
Okay. Saya tu.
Okay. Period. You have question, right, Period?
Yes, doctor. So the 20 pages is included, the cover, the table of contents, everything.
No. Actually, no.
Excluded?
20 pages does not include the table of contents. You see, when you put table of contents, right, you won't number the table of contents. Am I right? You only number the pages, right?
Yes.
So does not include appendix. Does not include number of table of content. Alright?
Alright.
Okay.
Thank you.
Now, it's not specifically 20 pages. It should, maximum is 20. You can do less than that. Nak hantar 10 muka surat pun okay.
Alright. Thank you.
Okay, alright. Alright.
Thank you, Doctor.
Okay, thank you,
Thank you,
Mahfira.
Doctor.
Okay, Vivian.
Thank you, Doctor.
Alright, Fahmi. Bye-bye.